Welcome. Today we are exploring how to talk to AI more effectively. We're moving beyond simple questions to master 3 core prompting strategies: zero shot, few shot, and chain of thought. These techniques are the difference between an AI that guesses and an AI that reasons.
All right, I'm going to start. Welcome to the Ideas Annual Symposium. Each year we come together to celebrate our accomplishments and look ahead to another exciting year of research and education. Please welcome our Institute Director, Alex Zelle.
So this has been a year when a lot has been happening in the outside world. So we are living through a revolution with an unprecedented pace and agility. And so I thought that really in the next few minutes, I would just really like to talk about, what is the trajectory? We have to change pace, and we have to change trajectory and directions. And so I would like to talk a little bit about what I think we should be doing in the next few years. So what's ahead of us? And the big challenge here is the tension between agility and tenacity, and how can we compete in this world, and who are we competing with? So we see that industry is moving at an extremely agile pace. So basically half of the papers written in AI are obsolete in 6 months. How can we teach a semester course when we know that half of the material that we are teaching thinking of at the beginning of the semester will be either wrong or outdated by the end of the semester? And how can we repeat this then every year? Basically, we have to write a new course. So how can we compete with the billions of dollars that are spent on these data centers and the hundreds of thousands and soon millions of GPUs deployed? We can't, simply. And our faculty hires are for 40 years. And even though these people who we hire today as assistant professor into AI probably will be able to change the course of research direction, but they won't be able to change it kind of very rapidly. It will take a few years until they adopt. So how can we adopt in this new world? There is one area we can actually compete. And especially important to look at the Nobel Prizes 2 years ago, where both the physics and chemistry Nobel Prizes went to AI. And the chemistry Nobel Prize went to Google.
Let's start with zero-shot prompting. This is the most common way we interact with AI, simply asking a task without any examples. It relies entirely on the model's pre-existing knowledge. But when does it fail, and how can we make it better?
It's Thursday, March 26th. Hundreds of municipal leaders representing the vast majority of Albertans are in Edmonton for the annual Spring Municipal Leaders Caucus.
We're winning so big, nobody's ever seen anything like we're doing in the Middle East with Iran. And they are negotiating, by the way, and they want to make a deal so badly.
President Donald Trump says the U.S. is talking with Iran, but leaders in Iran still insist they aren't.
Big tech, your gig is over.
Praise from concerned parents after a jury finds Meta and YouTube liable in a landmark social media addiction trial. Good morning. Thanks for yesterday. It took me forever to get home.
I know. And it's really interesting because depending on where you were in the city, then you might have gone home to bare driveways. And, it was quite a system parked over top of us at the end of our show and then throughout the first part of the day. And then more snow for all of us. Right now in Legacy, -13, the school day forecast brought to you by the Alberta Teachers Association will sit around -14 this morning, wind chill values of -23, and by the afternoon -7. We're slowly climbing up in temperature, so our warmest values will actually be probably a little later in the day than normal.
Yeah, talk about a setback though with the temperature. I haven't seen the -14 in a little bit here. You're going to notice the snow out on the roads this morning. A lot of slippery sections out there, but the plows are out in full force. We have 5A Street Southeast reduced to 1 northbound lane for Scotia Place construction until early April. Access to Calgary Arts Academy and Saddle Dome parking can be accessed via Stampede Trail to 14th Avenue. Let's take a look here. This is one of our live shots of 16th Avenue and Stony Trail in the northeast.
Thank you, Gina. The province is preparing to lay out new rules for municipal governments. It comes as leaders from across Alberta meet in Edmonton this week. Mason Despatie joins us live. Mason, what's expected out of this announcement?
Well, Hannah, like you were saying, the timing here is key. It comes as more than 450 municipal leaders are already gathered for the Alberta Municipalities Spring Caucus. There, Municipal Affairs Minister Dan Williams is set to unveil proposed changes this afternoon, targeting how elected officials conduct themselves in office. The details are still limited, but the focus is on transparency, accountability, and clearer rules for councils. The caucus itself is focused on many of those same pressures, including election rules, councillor conduct, privacy, and policing. High-profile speakers like Premier Danielle Smith and Opposition Leader Naheed Nenshi are addressing the delegates today as well. Meantime, this push for accountability comes as questions around trust at City Hall are already front and center.
Now, imagine giving the AI a few practice rounds before the real test. That is few-shot prompting. By providing just 2 or 3 examples, we can drastically align the model's output style and accuracy with our specific needs.
I'm thrilled to announce this course on generative AI with large language models created by AWS and deeplearning.ai. In this 3-week course, you learn in depth how large language models or LLMs really work and how to use them in applications. This course's instructors are Antje Barth, Chris Fregley, Mike Chambers, and Shelby Eigenbroek, all of whom work full-time on generative AI at AWS and have supported many companies to build many creative LLM applications.
Because LLMs are so new, there's a lot of opportunities for everyone to build applications that just weren't possible before. And this course will give you a deep understanding of how to go about it.
In detail, some of the things that you'll learn are the transformer architecture that powers large language models, a technique called in-context learning, which is key to one-shot and few-shot prompting, how to adapt models to specific tasks and datasets, and also how to align the output of an LLM with human values using RLHF, reinforcement learning from human feedback, to make it more honest, helpful, and harmless.
At the end, you'll have seen or implemented multiple examples of code building and using large language models, and you'll come away with a rich intuition about how to use these models yourself. I hope that many of the code snippets you see in this course you also end up being able to directly use in your own work.
So, there's a lot to learn, and confident you've finished this course with a deeper understanding of how LLMs work and how you can use them. I hope you take this course and use what you learn to build some really cool applications.
But what if the problem is logically complex, like a math puzzle or a legal argument? Standard prompting often fails here because the AI hops to a conclusion too fast. This is where chain of thought comes in, prompting the model to show its work step by step. A visual breakdown of the landmark paper Chain of Thought Prompting elicits reasoning in large language models and why Let's Think Step by Step works. To really see the magic, we need to look at zero-shot code. Simply by adding the phrase "Let's think step by step" to a zero-shot prompt, we can unlock latent reasoning capabilities in the model. Let's see some live comparisons.
Welcome to this lecture on using large language models the way Andrej Karpathy does. Karpathy, former AI director at Tesla and a founding member of OpenAI, made a remark that stopped the AI community in its tracks. He said that LLMs represent an entirely new kind of computer, a stochastic, text-based computing substrate. And yet the vast majority of people are interacting with them the way someone might use a typewriter. One prompt, one response, done. That mental framing is the foundation of everything we will cover today. If you have ever felt like ChatGPT or Claude is not giving you what you really need, the problem is almost never the model. The problem is the interface between your intent and the model's capabilities. And that interface is your mental model of what an LLM actually is. Let's make this concrete. Imagine two people sitting in front of the exact same model, say GPT-4. The average user types a Python function to parse JSON. They get a function, copy it, and move on. Now watch what an expert like Karpathy does differently. First, they prime the model with role and context. Then they describe the constraints, edge cases, error handling, performance requirements. They ask the model to reason out loud before writing code. They review the output, push back on weak spots, and iterate. The final output isn't just a function, it's a reviewed, tested, explained piece of production quality code. Dramatically different result. This difference isn't luck or access to a special tool. It is entirely a function of how you think about and interact with the model. Now that we have established why the gap exists, let's map out exactly how we are going to close it. This lecture is structured around 5 core pillars that together form a complete framework for Karpathy-style LLM usage. Pillar 1 is the mental model. Understanding what an LLM actually is under the hood so your intuitions about it are accurate. Pillar 2 is token thinking. Learning to reason about how the model processes information is how you write prompts. Pillar 3 covers concrete prompting strategies, chain of thought, few-shot examples, role assignment, and more. Pillar 4 is workflow integration, how to embed LLMs into real engineering and research workflows rather than treating them as one-off tools. And Pillar 5 is recognizing and avoiding the most common expert-level mistakes. By the end of this lecture, you will have a systematic, repeatable approach to getting expert-grade output from any frontier model. Before we dive in, let's be clear about who this lecture is designed for and what we assume you already know. This is not an introduction to what ChatGPT is. We assume you have used at least one frontier LLM, GPT-4, Claude, Gemini, or similar, and you've run into the frustrating ceiling. The model just isn't giving you what you need. Ideally, you have a background in software engineering, machine learning research, or a technical domain where you need the model to help you produce precise, reliable, and sophisticated work. You do not need to know how transformers are trained from scratch, but a basic familiarity with the idea that these models predict tokens will be helpful. If you have that baseline, everything in this lecture will click. And as we move into Chapter 2,
You've now mastered the hierarchy of prompting, from zero-shot for simple tasks, to few-shot for style and pattern matching, and finally chain of thought for complex logic. Use these tools wisely to turn any LLM into a sophisticated reasoning partner. Thanks for joining me.